Hi everyone, my name is Srikanth Machiraju and I work as a senior consultant at Microsoft. I'm an author and a regular blogger. In this session, we are going to learn to build proactive bots using Microsoft Bot Framework. The following are the prerequisites for this course. You can download the slide deck from the description below. What is a proactive bot? In a normal conversation with a bot, the user sends a message to the bot and the bot responds. But in a proactive bot, a background state change will initiate additional communication which is sent to the user proactively. For example, you want to send an updated stock price to the user. Or for example, you want to send the time it takes for the pizza delivery to reach the customer. So in those cases, we can use the proactive bot design to build a proactive communication channel to the user. What does it take to build a proactive bot? We need an event trigger framework like an Azure function and a message queuing system like an Azure Storage Queue, a bot application, and a direct line API channel enabled. My reference to the Azure function and the storage queue is for example purposes. You can use any event trigger mechanism and a storage message queuing system from any other cloud provider or anything which is available on Azure. So let's see how a proactive bot is designed. A proactive bot is not actually a different type of a bot. It is just a design pattern which is implemented using a message queuing system and a queue trigger function. Now, in a normal communication, the user sends a message to the bot and the bot servers relay the message to the bot application which we have built. The bot application responds back to the user using the bot server, using your favorite channels and the bot framework servers. Now, in a proactive bot, when the message arrives from the user based on your business scenario, it puts a message into the storage queues. There is an Azure queue function which is put on top of the Azure queue, which is watching for a message in the queue. The Azure function is triggered as soon as the message arrives in the queue. The Azure function uses the direct line API to make a call to to our bot application which we have built. Now, direct line API is basically used for making a communication with the bot application. Normally, we would use Skype native channels like Skype or Microsoft Teams or Facebook chat window to make a communication to the bot built using Microsoft Bot Framework. But direct line API is an API which can be used to build custom clients. Like say for example, you want to build a Windows Forms application which talks to the bot application, you can use the direct line API. In this case, I'm using the Azure function which is used to which is used to communicate to the bot via the direct line API. Now, the communication which is made from the bot servers to the bot application appears as a trigger message. As soon as the trigger message comes to our application, it identifies the trigger message and sends a proactive communication to the user. Now, having said that, let's see how the application is built. I have Visual Studio 2017 here, and I'm going to create a new project. I'm going to name it Simple Proactive Bot. And if you're wondering how the bot application project template appeared here, just follow the prerequisites. You have a step-by-step approach to download the bot application project template from the GitHub and place it under the Visual Studio Templates folder. So I have created a project called Simple Proactive Bot. I'm placing under my repos. I'll just rename the repository so that I don't conflict with my existing directories. Say OK. So this is a project. We have a message controller and we have a basic dialog which just replaces the user's message. Now let's build the project. The build is successful. Let's run it. So don't worry about this. This is just a issue with my Chrome window. So I'm just going to use the Firefox to see if my bot is in fact running. Yes, it is. The other way to test communication with your bot is by using bot emulator. So just Google for bot emulator and you would get a application for Windows and Linux platforms to test the communication with your bot. Now, this is a bot emulator. Now, in order to communicate with the bot, you would need the endpoint URL, which is this. You need to put the HTTPS here and followed by the default endpoint, which is API-messages. Now, if you're wondering why API-messages, it is the name of the controller and API is the default route. So if I say connect, you should see a 200 response. If not, uh, since this is a development certificate, let's just remove the HTTPS. Yes, this time it is connected. And now if you say hi, the bot would respond with the number of characters. So our application, bot application is working fine. Just stop this, and try to publish this to Azure. Now I'm publishing this to Microsoft Azure as an app service, a new app service. So I'll select that and click publish. I'll name it Simple Proactive Bot. Hosting it in Southeast Asia data center. I'll use a free plan for now and click create. It will take a couple of minutes for the application to be deployed to the uh, Azure subscription. So the application is published. Let's see if the application is running. Yes. Now let's see the application from the Azure portal. So this is the Azure portal. And if you search for simple proactive bot, so this is the app service which we deployed. Right. So this is just any other normal web application. Now let's configure a bot. Let's do a bot registration for this API. In order to do that, just say create resource and search for bot channel registration and click create. Let's name the bot as the simple proactive bot. Right. I'll use an existing resource group. And my API, the messaging endpoint here in this case is this. It has to be always HTTPS when you're doing the registration and followed by API slash messages. I'll turn off the app insights for now. We need to register the bot in order to get the authentication app ID and the password. So let's just do new and create an app ID and password. So sign into the account which you have used to publish the bot. So this is the app ID. Let's just copy that, and the first place which you have to put the app ID is the web config of your application. This is the Microsoft app ID, and let's just generate the secret or the app password. So this is the app password. I'll put the app password here, and you'll have to do this again at the bot registration. So let's go back here and copy the Microsoft app ID. and the password, and let's just say okay and click create. Again, this is going to take a couple of seconds for the bot channel registration. There you go. The resource is ready. Let's go to that resource. So this is the bot channel registration. Now, since we have made changes to the web config and the bot API has to, the bot application has to authenticate with the bot servers, let's just republish this app service. Right. So now come back to the bot channel registration window on Azure portal. Click on the test in the web chat and say hello. So the bot response, which means our authentication, our deployment was successful and the bot authentication was also successful. Now, let's come back to the presentation. So we have successfully deployed a bot application to the cloud. The next step is to create an Azure queue and put a message into the queue when a message arrives from the customer. Let's do that. So in the root dialog, when the message arrives, it it comes here and it the user the bot responds with a default message. So let's just put some code here which is going to enqueue the message to the storage queues. Now, this to put a message into the queue, you would need the cloud storage account, and of course, you would need the NuGet package, which contains the libraries for connecting to the Microsoft Storage Azure Storage account. Let's install that NuGet package. Um just search for Azure Storage, and this is the NuGet package you have to install. So the package is successfully installed. So let's bring in the namespaces. Okay. The queue message is a class which I've created, which is a serializable class. So I'll just take this class from the snippet, and for simplicity, let's put it in the same namespace. The resumption cookie is a pre-built class which comes from the Microsoft Bot framework, which is used to store the username and the service URL, and it is a serializable class, so it goes along with a message into the queue. I'll just get back on the usage of this resumption cookie. So you have a message which can be put into the storage account queue. The name of the queue is bot queue. Let's just build it. Right. So you would need a storage account on Azure in order to connect. So let's go ahead and create a storage account. Okay. Say create. Say simple proactive bot storage. It's gonna be okay. Is it available? It's already taken, so let's put one here. Okay. Um, I'll make it locally redundant and use the same resource group. This is important so that you put all your resources in the same data center and click create. So the resource is available now. Let's go grab the connection string. So this connection string goes into our web config with the name storage connection string. Just make sure the naming convention name is correct. I'll just grab it from here and paste it. All right, let's build it. So let's publish the changes. Right. So the publish is successful. Let's go back to our bot registration. Now, if you try to test it with a different message, hello bot, there would be a message in the storage queue. So how do you check? So just grab the connection string, which is in the web config. So open a storage emulator. You can just Google for Azure Storage Emulator. You would get something like this. Let's add the account. Put the connection string here. Connect. So go to the queue section. So you see that bot queue is created and there is a message. So the message which you have sent is hello bot, and the resumption cookie actually carries the bot ID, the channel which is used by the customer, the user ID, the conversation ID, and the service URL. Now let's close this and go back to our presentation. So what we have accomplished so far is that we have created a bot application. It is hosted on cloud, so the bot servers can talk to it. The user, when he sends a message, the message arrives at the bot application and it is put in the storage queue. Now the next step is to create an Azure function which is picking the message from the queue and sending it back to the Azure Direct Line API endpoint. Let's just do that. Now go back to the Azure portal and let's create a new service. uh, Azure function. So you'll find Azure app, function app, and a function bot. Function bot is to build a bot from the scratch, which we are not doing. So let's go create a function app. See, name the function as proactive bot function. If I'm lucky, I would get that name. Okay. So I'll use the existing resource group again. It should be in Southeast Asia. And you need to choose a connection storage account here. I'll select the storage account which we just created, proactive bot storage 1, and click on create. The resource is available. Let's just go to the function. Right. So this is an account which doesn't have any function. Let's just create a function. This is a data processing function, and we're choosing C# as a language. So this is, it creates a function. This is the code. Let's just grab the code which we want to put run here when the message arrives in the queue, and save it. So if you look at the code which is pasted here, it is waiting for a message which by name myQueueItem to arrive in the queue. It just creates a new bot message out of it using this class and just returns the message. Now to integrate this with the queue which the bot which we have built, let's use the input trigger as the storage queue, Azure storage system. The message parameter name here is myQueueItem, and the queue name is the bot queue. And let's connect this function to the same storage account which we have built. Okay, so we are the function is connected to the queue. Now, now let's just create an output here. The output would be to the bot framework. The out parameter name is message. I'll just explain why it is called message. The sender ID is the bot application ID, which is in our web config. So let me just go and grab that. Now we need a direct line API key. So in order to get that, I have to log in to the Azure window, Azure portal in a separate window, and just search for my bot. I think it's here. Let's just go there and go to the channel section. So you'll find a lot of channels here. I'll just enable the direct line channel. So this is the key we are looking for. Just copy it. I'll put it on a notepad so that I can reuse at multiple places. Click on done so that the channel is enabled. Now another window, go back to the Azure function and copy the key. Click save. Now coming back to the reason why it is called message, it is because of the code which we have written here. The input parameter name is myQueueItem and the output parameter name is message. So we have to ensure the parameter names are correct. So we have the input message parameter name as myQueue and output as message. Now if you go to the monitor section, you'll see that the function might have already triggered because there is a message in the queue. If not, let's just run that. Okay, sorry. So there is an additional setting which you'll have to put. So you go to the Azure function and under the app settings, I'll just wait for it to get enabled. Just try that once again. The proactive bot function. Okay, in the app settings, you have to put the direct line API key with the name as the one which I'm just grabbing from here. It's called Azure Web Jobs Bot Framework Direct Line Secret. Make sure the name is the same, and the secret is the direct line API secret. This is the reason I wanted to put it on the notepad so I can copy it at multiple places. So these are the two places which we'll have to ensure that it is copied. So that making sure the save is successful. And here you in the bot function, in the queue trigger function, you can hit run to test. So you can see that it has picked up from the queue and it has sent a message to the bot application. You can watch the log of the Azure function from the monitor section. It's just not yet there. Let me go and check from the Azure Storage Explorer. So this message is already read. So let me put a new message from the chat window. Say hello again. So this should arrive in the queue. Maybe it's already picked up. So let's just look at. All right, there you go. So this is the message which was picked up earlier. Hello bot. It's just taken some a while for the messages to arrive. So this is the latest message. These are the two messages. Hello again. So these are picked up by the Azure function and they are sent to the direct line API channel. But but if you look at the code which we have deployed to the as our application in the bot application, we don't act on the message which arrives. So the message comes as a activity type as a trigger. So let's just add some code here so that it reacts to the message sent by the Azure bot function. So if the type is of type trigger, let's do something here. So what do we do? Just relay the message. Let me copy that code from here and bring in the namespaces. Right, just build it. Okay, so if you look at the code which you have pasted, what it does is it just serializes the object message which arrives in the queue and it establishes a channel using the service URL which is in the message, which is in fact in the resumption cookie which we have used to put in the queue. And it creates a reply to the user using this text. So this is the way you create, establish a connectivity from using the direct line API channel. So let's just publish this. Okay, it is published. So we can go back to our bot and say back again. So what happens here is the message is sent to the bot. The bot puts a message into the queue. The Azure function is triggered. It sends a message to the direct line API endpoint and it is sent back to the bot as a trigger message. Since the trigger message is responding back to the user, it is sent back to the user as a reply. There you go. Now this completes the build proactive bot building session. But let's say if things go south and you've messed up somewhere, how do you debug? So let's learn some debugging techniques. The tool I'm going to use here for debugging is called ngrok. You can just click the link below and download the ngrok. So I have it placed in my C drive. So let me just build it up, bring it up. So this is the ngrok.exe. It is running here. So what you need to do is just run the command on your local machine. So this gives you a tunnel. ngrok is basically a tunneling software which creates a session on your local client. So any request which come to HTTPS this URL is actually relayed back to localhost on this port. So let's run the application on a local application, local machine on in a debug mode, and put a breakpoint here and here. Let's not worry about this. I can test it from my Chrome window. Sorry, the Firefox window. So it is live. Okay, so the first thing which you need to do in order to test debug your bot is go back to the uh, settings and change the channel register configure endpoint, messaging endpoint. I'm sorry. So this is going to be the messaging endpoint. So when the message arrives, it sends the message to this endpoint uh, and it is relayed back to our local host. Right. Let's just remove this so that the changes kick in. Yeah, save. Now let's go back to the. Hopefully my changes are saved. If I go back to the test window and I'll just okay, it already started because of the bot being active. I'll just let this go. Okay, so let's watch what happens in the ngrok when the message arrives from the bot. Let's bring the windows side by side. The moment you say hi, the message is tunneled back using the ngrok to our Visual Studio. And the message arrives in the queue and it is taken by the Azure function. Sorry, just jumping here and there. Let me go back to the presentation. So the message arrives in the queue and it is taken by the Azure function. It is sent to the Azure Direct Line API and it is sent to the bot. Since the bot is connected to our development environment, it invokes the local host. So this message is what we have sent. It is a trigger message. So you can debug the code. So this is the hi message and you can easily test the changes. That could be because of my development machine stopping it. Okay, so this completes the um, debug scenario. So let's summarize what we have learned today. We have created a normal bot, published and configured the direct line API channel, We have created a storage account and make sure the message is enqueued into the storage queue. And we have created an Azure storage function on top of it, which is triggered whenever there's a message in the queue. And the Azure function creates a trigger event which the bot application responds to and sends a message proactively to the user. So this completes our learning on building a proactive bot using the Microsoft Bot framework. If you have any questions, just write to me at vishwanath.srikant@gmail.com. Thanks for listening.